Let's take a look at the titration curve of another amino acid, this time glutamate. So we start with the fully protonated form, which has a net charge of +1. This will be followed by the Zwitter ion. So the proton from the carboxyl group attached to the alpha carbon is removed, followed by a negatively charged glutamate, so -1. And this time, it's the proton from the side chain carboxyl group, followed by the form which has a net charge of -2. So the proton from the amine group is removed. So again, we observe a slight rise in pH, followed by the buffer region. And then there is a very small change in pH. We observe that at equivalence point, the pH change is always steep. But this time, we hardly see an inflection point. And then we observe again the second buffer region or the second pK value. And after this, we observe the steep change in pH, which is equivalent to the third equivalence point. The second equivalence point. And then we see the pK value again or the buffer region. And we see the invisible third equivalence point. So just like glycine, the last equivalence point takes place at a high pH value. It's impossible to measure it with the pH meter, so we don't see it in our titration curve. Now let's discuss this region of our titration curve. So we hardly see the first equivalence point, right? This is because the two pK values are very near each other. We have 2.19 for pK1 that corresponds to the removal of the proton from the carboxyl group attached to the alpha carbon. So it's this dissociation reaction. And followed by pKr, which is at 4.25. So the two values are very close to each other. So this one refers to the removal of proton from the side chain carboxyl group. And this is the reason why we don't see the equivalence point at all. So it's hard to notice the equivalence point if you just plainly look at the titration curve, because we expect that at equivalence point, the pH change is very steep. So this is a consequence of the structure of your amino acids. To be more specific, the type of functional groups that you see in your amino acids and their structural effects. Notice the PI is marked here, it's 3.22. So how do we determine the PI? We get the average value of the pKs surrounding the Zwitter ion. So what you do is you write this series of structures. So the protons is getting removed one by one. This is your Zwitter ion. So the two pK values flanking this Zwitter ion is pK1, which is 2.19, and pKr, which is 4.25. So get the average of these two values. That will be your PI or isoelectric point for glutamate. Meaning, if the pH of the solution is equal to 3.22, all of your glutamate molecules have a net charge of 0, so they will precipitate out of solution.